All right, well, the clock on my phone says 7 o'clock, so we'll just go ahead and get started. Thank you, everybody, for joining us tonight. And I'm sorry I can't see all of your faces. I only see like 4 or 5 people on the sidebar over here, but really glad that everybody's able to join us virtually for Ajug. And one day, again in the future, we will be able to congregate in person and enjoy pizza together. But thankfully, technology allows us to still host our meetings every month. And in this case, we're able to have a speaker who wouldn't normally be able to come see us and speak with us. So very happy about that. I'd like to thank all of our wonderful sponsors. Without our sponsors, this meeting wouldn't be possible. DevNexus wouldn't be possible. I won't read all of these to you, but many of these names should be familiar. They're very helpful in keeping us going. We've got some upcoming events to talk about. First up, I want to introduce Ari Waller. He's going to talk to us about something from JFrog.
Yeah. Hey, thank you so much. I really appreciate it. Hi, everyone. I'm Ari Waller, and I'm the Meetup Event Manager for JFrog. And I'm really excited to be here tonight with my home JUG as a proud sponsor for Ajug. JFrog, for many of you who may not know, is a software company founded in 2008, and we are currently based in Silicon Valley. We're known for our flagship product, Artifactory, which is written in Java. We have an OSS version of that that's actually older than our company in 2006, which supports Java and Maven and Gradle. So if you haven't checked it out, give it a try. Today, JFrog has over 600 employees, 10 offices globally, over 6,000 customers, a real success story, and more than 3 million developers use our software tools on a daily basis. Tonight, as a sponsor, we just want to provide a little quarantine cheer, a monthly sweepstakes. As you can see on the screen there's a QR code. At the end of June, JFrog is drawing 2 winners for a Nintendo Switch Lite and Animal Crossing game. They're sold out everywhere, so if you've tried to get one, this could be your chance. Also, those who enter tonight are automatically going to be entered to win one of the JFrog, if you can see it here, Iron Frog t-shirts, which are new this year. And we will actually, we're going to do a drawing at the end of the night. So try to enter that as soon as possible so you can get your chance. And I'll put the link to the chat window. The last, if you wouldn't mind changing slides one more.
Yep.
The last thing I want to mention to you is we have our annual JFrog DevOps conference. It's Swamp Up 2020, which is going to be online. It's a lot different than it was before. We really, on June 24th, are encouraging a lot of people from the developer community to come, as we have some really fantastic speakers coming in. As you can see, these are some of them. Bernard Burns, co-creator of Kubernetes, the creator of Jenkins, just a lot of great names. And if you look on the site, you'll see even more, and I'll send you that link shortly. Just so you know, 100% of all ticket sales will be donated to COVID-19. The cost is only $20. But we also want to offer at least 5 tickets to Ajug tonight. And the way that's going to work is I'm going to put the code, or you actually can see the code here if you want to go sign up now. The first 5 people that use that code to register for June 24th get in free. So that's pretty simple. And we'll actually let you know that JFrog is going to donate that $20 on your behalf. So the COVID charity is not going to miss out by you getting a free ticket. So we would love for you to attend. And again, just real excited to be here tonight. If anyone can ping me anytime. Again, I'm here based in Atlanta, and looking forward to the talk this evening. So thank you very much, Roy.
Thank you, Ari. And we've got one more meeting to announce. Next month at Ajug, we are doing a really special panel about diversity in the workplace. And we got some great speakers who are going to come and have some good conversation and answer questions. And really looking forward to that. And hopefully you can join us next month in July. And with that, is anybody hiring? Maybe you can, I don't know, can anybody unmute if you are hiring? Going once. Do you see anyone, Glenn? Because it's hard for me to see all of the.
No,
Okay.
I don't see hands raised or, well, old hands that were raised before. So if you're too shy to speak out, just hit the chat window and just let's see.
Yep, no worries. If you've got,
Don't worry about it.
yeah, if you've got any postings that you
Yeah.
want to share with us, feel free to add it to the chat window.
Yes, please.
Thank you very much. And if anybody's interested in hanging out after the meeting, we can continue the conversation then. Just stay on the Zoom and we'll continue the chat. And with that, I'm going to turn this over to Greg Turnquist. I guess I will introduce you, Greg. So Greg is a coworker of mine and Glenn's. He works on the Spring team, on the Spring data team, I should be more specific. And you might have heard that he's authored a few books. Really excited that he's able to join us virtually from Nashville, or I should say a suburb of Nashville, shouldn't I? And with that, Greg, I'm going to turn it over to you.
All right, thanks everybody for inviting me to come speak. Glad to see you, Atlanta JUG. To be precise, I live in the suburbs of Clarksville, and yes, if you want to catch the last train to Clarksville, I'll meet you at the station. But today we're going to talk about reactive relational database connectivity, or what's known as R2DBC. Before we get going, just a little intro as to exactly who am I. Since you can't, if you're looking at my thing, you can't see my avatar, so a little headshot. I've written a few books, and then I actually have a new one that just came out last month, Hacking with Spring Boot 2.3 Reactive Edition. So if you go visit bit.ly/hacking with Spring Boot, you can go get a peek at that. So I've actually now authored 2 different books that are aimed at the 100% reactive based programming model. And so I encourage you to go check it out. I've often referred to myself as a test-bitten script junkie. If there's a solution that involves writing a Python script, I'll go do that. Hail Python. I'm also a principal developer on the Spring team at VMware, formerly Pivotal, formerly VMware. I'm an author, speaker, one of the co-founders for the Nashville JUG. I'm a committer to multiple projects like R2DBC, Spring HATEOAS, Spring Boot, and Data. And I'm actually the project lead for R2DBC H2 driver, Spring Session for MongoDB, and Spring Web Services. So if you ever want to discuss SOAP, then you can call me if it's really critical, but I'd rather go back and work on REST, not SOAP. But I'm a coffee lover and a dad, I noticed all these had so I made dad to be funny. And I'm not really addicted to coffee. We're actually in a committed relationship. So what is it about reactive programming? It's kind of a buzzword. It's been really gaining a lot of momentum in the past couple of years. Reactive programming is kind of the next frontier when it comes to Java, especially when you talk about high efficiency applications. We're kind of in an era where, hey, I really can go throw more servers at the problem very easily. Amazon or Google, whatever, will happily take your money to go spin up 10,000 more instances. But the problem is, can you afford that? So a real question is can I squeeze more out of the servers that I have, or do I even need this many? Is there a more effective way to do that, to use what I have? If 10,000 machines are running 80% idle, maybe there's a solution to it, and the solution is reactive programming. Reactive programming is a fundamentally non-blocking concept, and it's often paired with asynchronous behaviors, but reactive itself really doesn't hinge on async. There's, in fact, synchronous flows with it, but you don't want to be blocking necessarily. And a big difference when you get into reactive stuff is there's a concept called back pressure. And at a fundamental level, the idea is I can have in a flow of processing where a certain series of steps needs to be carried out. One process in a chain can say, well, okay, I've just produced 10 of these things. I'm going to push them downstream to the next consumer. And in the olden days, this would cause traffic blockages. And the number of times I've driven through Atlanta at rush hour, I've kind of seen that face to face, like here's what happens when you shove too many cars onto the interstate all at once, it kind of gets jammed up. So the idea with back pressure is that the client downstream can say, well, I see you have 10 items. I can only process 2 right now, so I will take 2. You have to wait till I call for the next set of stuff. And this whole concept flows up and down the stack. of being able to exert back pressure and have a sense of control. Now here's an example of a reactive operation. This is a Spring Web Flux endpoint where someone's going to query and say, give me the health of the system. And this method is supposed to calculate a composite health. So it's going to use the reactive web client from the Spring framework and reach out to Alpha service and reach out to Bravo service and get back both of their health statuses. In the olden days, you would either execute one, your thread would sit there and wait idle, waiting for the response to come back. Then it would go and make the second request. It would sit there idle and wait for the second request to come back. And then it would composite the results together and give the answer back. And you could add up how much time was spent actually carrying out work versus how much time was spent idle. And the whole thing is the incoming thread call is just sitting there and it's being held up and it can't do anything else while it's waiting on that. The concept of reactive programming in this code example is that you can actually, if you start from the inside and work your way out, there's two different web calls. They can both be issued. You can say, okay, I need both of these, but I want the results zipped together. Zip in reactive paradigms is sort of like saying, go do both of these. When both of them are completed, whenever that happens, come back to me, and then I have another step to carry out. And that's at the bottom where you map the results and say, now I want the results of part 1 and part 2, and I'm going to run them through a composite function that somehow decides how those go together for a roll-up health status. So Mark Paluk, the lead for Spring Data, has called this reacting to resource availability. So that is, this could all be carried out by a single thread. It could be carried out by a multi-thread. The threading is not directly visible here. Instead, it's let's go carry out these two operations as resources become available, and then let's combine them. And while we're waiting for the results to come back, the thread is released and can go do other work. It can answer other web calls, it can go carry out other activity. The threads are not being held up waiting for this results. So that, in a sense, lets you stop having all this idle time that's eating up your cloud budget. However, if you say, wow, that sounds like a great idea, I want to go pick it up and embrace it, there's still some roadblocks out there to adopting reactive everywhere. One of the biggest is the lack of back pressure when you go over a network call. So if you make an HTTP call out to one of these remote services, you no longer have the ability to use back pressure. There's no way to express back pressure over a network connection, at least if you use HTTP as your communications protocol. However, there's a spec being developed and an implementation called RSocket, which is the R's for Reactive Stream Socket. It's a layer 7 network protocol that's analogous to HTTP, but it actually speaks back pressure. So you can actually communicate over the wire this information about, I've got 10 objects, are you ready for them? And whoever's downstream can say, no, just a second, I can only handle 2. And that's not part of tonight's talk, in fact, but it is actually, there's a whole chapter 8 of my book, Hacking with Spring Boot 2.3, goes into RSocket and the different paradigms you can do with that. There's also, if you go into data access, you'll find that there are new drivers out there. If you're using MongoDB, Cassandra, Couchbase, Redis, or Neo4j, they all have reactive drivers that can speak this new protocol. However, if you go out to Postgres or MySQL or Oracle, you're not going to find a relational database access that's reactive. Instead, you're going to be stuck with something like JDBC or JPA, which is a fully blocking API. And so the problem with any reactive solution is it needs to be reactive from the top to the bottom. Otherwise, all this non-blocking hits the database and then you're held up waiting for a response. And so there's no, you lose all the benefit when you do that. Thus was born R2DBC. I believe it was first announced at the 2017 Spring 1 platform during the keynote. And R2DBC is an API that was designed from the ground up for reactive programming, for reactive relational database connectivity. And here we're going to go through, a little bit about what the basics are, and then later on we'll actually have a demo to look at a sample application. So some of the basic design principles that the Spring team picked up is that we want to utilize the reactive streams, types, and patterns. Now, I've been talking about reactive programming in general, but I want to be very clear that the protocol we're using is specifically reactive streams. When I talk about back pressure, that's something that you can find at in fact, there's a website at reactivestreams.io that actually has the specs, that has their types of basically it's a publisher subscriber paradigm, but it has this negotiation built that includes that back pressure concept. And so the idea was to build R2DBC on top of that. And in the sense, we want it to be completely non-blocking all the way to the database. And this means going to each database and speaking in their wire protocol. We're using as many features as possible. So there's code talking to PostgreSQL. So it's not a wrapper around somebody else's JDBC driver or a wrapper around somebody else's JPA driver. This project involves write a driver that speaks directly to the database and then leverage reactive streams, types, and patterns. Another one of the goals was to craft an SPI at the driver level to have an absolutely minimal set of operations that are implementation specific. So the first duty is to have it. Let's have an SPI that's actually the smallest possible, so we can make creating drivers as easy as possible. And on an upcoming slide, I'll explain why that choice was made. That in the sense, if we have to sacrifice usability, that's okay. Let's try to make the drivers surface API as small or SPI as small as possible. And the outcome of that, let's make it possible to create humane APIs on top of the driver. And by humane, something that developers want to use. Now, one of the biggest things to go look at and learn from is let's look at JDBC. You can't talk about Java and databases without thinking about JDBC. It's a spec that's been around for a very long time. It's been both very successful and it's had some big gaping holes in it and failures and stuff. And if you start getting into the depths of writing JDBC drivers, you start to get nervous, and have, there's a lot of crazy stuff if you start talking about people that have to interact with JDBC at a very low level. And the thing is one of its core problems is that it has sort of one API that defines both how users talk to the database and how the drivers talk to the database. There's one API that bridges them together. So whether you're writing a MySQL driver or you're creating JUG or JDBI, a client library, you're talking to the same API. And you end up with sort of a compromised situation that's not necessarily good for all parties. And you get an API users don't like using, the driver authors don't like it, and you run into, there's circumstances where things like binding to variables, the question mark binding, the different JDBC drivers have different binding options, but basically every driver implementer has to implement that paradigm to service the libraries. When it's like, that would have been something useful to put in the spec, but then that would have pulled the API down to a lower level that the users didn't need to. So R2DBC seeks to kind of have two different approaches to that. Let's have a driver level, and then let's have a client user level. Now, these next few slides show some bits of code that are based on using the SPI. If we kind of work from the outside, from the inside out, you can see at the center there's a create statement call. So, a common pattern is to have a connection factory. You've seen that in a lot of different third-party toolkits you connect to. In this case, you have a R2DBC connection factory, and when you get inside there, you're able to create a SQL statement, select value from test, and then you can execute it. These are SPI command statements that are part of the R2DBC spec. Then once you get the results, you can flat map over them, and flat map is part of the project reactor. What our implementations are using is we actually use project reactor, which is VMware's implementation of the reactive stream spec. But we do return, if you'll see the top, it says publisher object is the return type. We do return reactive stream types. But you flat map over the results, and then you go into a row and you say, I want to get out the value. So essentially, I want to run the select statement and I want to extract the value column from that. And By flat mapping over that, you're able to hand back a sequence of objects in this sense. One thing we're able to take advantage of is the fact that, JDBC itself predates Java 5. There people were connecting to JDBC before we had support for generics, but we have full support for generics baked in from the ground up. So you can specify, I want to get this column, and it is a string type. So I can hand back a sequence of strings reactively. That's a simple select statement. And again, using the SPI, it's also possible to create like we call it a prepared statement. So create the statement, but then do binding against it. So here we bind the first argument and the second argument of this insert statement, and then add it, and then do another pair bind. So now that translates into 2 insert statements, and then execute that. So you can kind of read that, you can kind of pull that apart, figure out what that's doing. There's support for transactions in doing sort of the same thing. So you can, with a connection, you can begin a transaction, go create your statement, put in you can delay it until the commit is done. And then you can also have rollbacks. In this code, there's a lot of mixture between talking to the SPI and then having to do some of the reactive programming dance. So if you've never seen reactive programming before, this is probably like crazy. So, and we recognize that. So that's nice. We've got that's like a sort of a first level step into, okay, this SPI can talk to the database. It can do it in a reactive sense. And, but that is some verbose code right there. Now in reactive programming, a fundamental concept is you can set up all these patterns like I'm gonna do a select statement, I'm gonna do a transaction, I'm gonna do all this stuff. But nothing happens until somebody subscribes for the results, until somebody at the end of the chain basically pulls on the thread and says, I want the results from that. And so connections aren't opened, cursors are not allocated until somebody subscribes for the results. Now the driver SPI has a minimal set of operations. So there's a bare bones enough to actually go do something, and nothing more than that. It's usable, but it's very verbose. You kind of need to know what you're doing. And it feels very similar to the the JDBC days of I got to write try catch statements around every single operation. I need the finally clause so that I can do the right resource management, which you ended up putting try catch blocks in your finally statements. And I'm sure many of you can remember the heartache of all that, which is why we reached to toolkits and other client libraries to do some of this resource management ourselves, for us, that is. So what we need is a humane client API, something that can consume that SPI we just looked at and make an easier interface for the end users. And in fact, R2DBC encourages anybody to go in and go write your own end user humane API to do that. So the first one we did was this other one that we coded, and it's kind of similar to JDBI. So if you're familiar with JDBI, this should look familiar in the sense you open it, you have a connection to the database, and you have a handle on it. So the handle has some simplified operations. So in this case, you'll do a select statement, and then you can map the row. So this is how to transform the results into your final type. In this case, it's just doing a string type. But if you were trying to map this onto some POJO class, this would be your place to expand the Lambda expression or into a more complex thing, and you could map it all into a type. If you've also used things like Spring's JDBC template, this looks like a very analogous concept. So all the resource management is wrapped up in the with handle operation, so you don't have to deal with that. You don't have to do all this connection factory management. The prepared insert looks very similar. You create your update operation. You still do binding. That's a pretty straightforward operation, and execute it. But no more of that resource management there. That's all handled by this particular client. If you need to do the whole thing in a transaction, that transactional statement I saw earlier was very complicated to get it right. This client makes it very simple. And so instead of, if I just flip to the previous slide, either with the handle, you're doing the operation directly bare, or if you need it wrapped in a transaction, all the statements in here will be, It'll do the begin and then the complete, it'll commit the transaction at the end for you. There's even a Spring Data R2DBC project that has a database client that you can use. So all you have to do is wrap that same connection factory, which comes from the SPI, and poof, you have a client that can write something a little more savvy like this. You know, do an execute statement. Here's your SQL. Here's the binded arguments. You know, it needs to transform it into this type. Now it's all a small fetch operation, and poof, you have a collection of person objects. Now, something that I may have skimmed over a bit is earlier we saw a publisher object, publisher string. Here we're seeing something called flux person. So publisher is sort of a vaguely similar to like a future. That's a reactive streams type that says there's something in this object. I'm holding on to a sort of a promise. Something is coming sometime in the future, and I don't know when. And it could be one or more things. It could be multiple things coming, or it could just be one. So it's kind of like future in that sense, but future is typically done. Future is used around something that's already been initiated, and you're waiting for the outcome. With publisher, you're like, there's a promise that will be fulfilled if somebody subscribes. If nobody subscribes, then nothing is ever coming. And what Flux is Project Reactor's implementation of that. Project Reactor has a Flux type, which is one or more things. In this case, one or more person objects are coming when they come, when the database is able to serve them. And there's actually a special type. If you know that there's only going to be ever one thing coming, there's also another type called a mono. So there's a mono person object. So now the next thing up, that if any of you have used Spring Data, the repository-based solution, that's another level up. That's a lot more like the way you can think of it as JPA operates. But in this sense, what it is if you extend the Reactive CRUD repository interface from Spring Data R2DBC, it gives you the ability to create, first of all, you inherit a series of CRUD operations. There's a save operation, save all. You can also find by ID, find all, delete, and then save is used for both creating and updating. But then you can go define custom finders, and it's an interface definition that you don't have to implement. Spring Data actually creates a proxy that goes and implements it for you. And actually, something that's in the demo is the fact that now you can either write out the query yourself the way it is on the screen here with an @query annotation, or something that was added to the project in recent months is there's something called query derivation, where it can actually look at the method name and figure out the query it needs to write for the database you're talking to. And then down at the bottom, you can actually invoke the repository. So, you don't even have to think on the level of, I need to open a connection factory, I need to connect, run this particular SQL statement. Instead, you're able to really move up to a much higher level and start thinking more in what's the business case I need to solve. One last thing before we get to the demo part, which will be a little more wheeling and dealing, is the fact that the spec is also defined connection URLs. So we do have the SPI, the project has a parser for R2DBC URLs, and so you can either have it's open, or you can signal it's over a secure connection with the S on it. You can either be talking directly to the database like PostgreSQL, or you can be connecting through a pool. So R2DBC actually has a pool solution. So pooling in reactive problem spaces is not identical to plain old pooling. So you can't run out and grab Commons pool and throw it into your active project and have it work the same. A lot of these things will work with thread locals and stuff, which is a big no-no in reactive programming. But essentially, you can use the connection factories from the thing and say, here's the ID, give me back a connection factory that can talk to that database in the right dialect, and it'll do it. So, as promised, let's go to demo time. So I'm going to go put this thing into, go to presentation mode. It's my favorite mode here. Okay, so one of my favorite paradigms the favorite app I just love to run out and build is payroll systems, because that's just, what I live for. So, and the cornerstone of any payroll system is we need the concept of employees. So we need people, we need like an employee needs a name, they need whatever their role is on the project. We need an ID field as well. And so we get to mark it. Now we don't have the benefit of Java x.persistence.id on hand because we don't have that. So this demo, we're actually going to use Spring Data R2DBC. So in this case, the Spring Data Commons project has an ID field to denote where's the ID column on this Pojo type. I've got a couple constructors here. One is what I use if I don't know what the ID is. For example, if you're going to create a new row of data and write it into the database, then you don't know what the ID is. And so if the ID is null, then Spring Data will go and create a new ID for you. But I also do need a all-in, fully constructor call that covers all the fields. And what I can do is I can tell Spring Data R2DBC that this is the constructor it needs to use when it needs to instantiate a Pojo. So go and use this one when you're creating stuff. For this demo, I'm actually going to also build a JSON-based API to do it instead of a web page. And so my favorite choice is to use Jackson. And so Jackson also needs to be alerted that this is the constructor call that it needs to use. And that's why I also have all these JSON property annotations filling up my constructor call. And the rest is just boilerplate. So whether you're using Kotlin or Project Lombok and getting away from all that, it's your call. Now, I am going to go pull up a, now for any fun demo, I always like to use H2 as a nice in-memory embeddable database to get things going. And so what I want to do is I want to initialize and put some test data in here. So one thing with Spring Data R2DBC is I could load the schema here directly, but I like delegating it to a nice little schema file. I can pull that up. Oh. Where's that? Ah, here it is. Okay, so create table employee. These are all the basic fields I need. That's good. Let's go back to that database initialization. So when this bean fires up, it's going to basically tell the system, go run this SQL file. This should create the repository for me, not to be used in production. I'm also using Spring Boot. And so Spring Boot comes with a nice little thing called a command line runner. So if you go create a command line runner bean and register it in the application context, Spring Boot will go and run that code after the application has started. Now, if you create more than one command line runner, there's no guarantee what order they're going to run in. So don't try to choreograph stuff between. But in this case, it's basically hand me a copy of a employee repository, which we'll look at in a second, and I want to use that repository to store a couple pieces of data in. In this case, I want to load my two favorite employees, Frodo Baggins and, of course, Bilbo Baggins. I'm not sure why you want to put a burglar on your payroll. Now, the other trick in all this stuff is that I said earlier, nothing happens until you subscribe when you're doing reactive programming. And so if I had coded just this, in other words, if I didn't have, if I was just here, repository I'd save, and I ran the code, that first statement, nothing would happen because nobody is pulling for the results saying, I want to see that verified. So you have to do either something like this, where you say, I'm going to block for the results. That's one way to do it. The blocking says, okay, go do that now. Go get on it. But what I'm using here is, let me uncomment this chunk. This is actually a bit of code from Project Reactor's test module. So they have an actual test thing to help you test out reactive flows, and it's essentially does the subscribing for you. And it says, okay, go take this whole operation and wrap it in the step verifier from their test module. Verify that one result came back. In other words, this should have saved one row of data. So I should get one thing back and verify that it completed. And so, and then do this for the other one. So with this, I better go create this employee repository. So here's the employee repository, which looks somewhat similar to the slide that I showed earlier. It extends this reactive CRUD repository this is defined in Spring Data Commons, a shared library between all the Spring Data modules. And it defines this particular repository, what's it for. This repository is aimed at employee objects, and what is the type of the ID field, the column that the key is gonna go in, and it's a long. Now I can actually just do that, and I would actually have an operational repository here. And you'll notice, I mean, it's an interface, and nowhere do I actually have to implement an interface. And this is where I like to segue into the Spring Data side of things. So R2DBC doesn't provide this reactive CRUD repository. This is Spring Data R2DBC using R2DBC's SPI. And that really sounded like a lot of $5 words right there. But the concept is I can define what the operations are, and Spring Data will go and actually, in a sense, implement them without using code generation. Instead, it actually creates a proxy to chain stuff together. If I can actually go look up what's in this interface and find operations like save. And I mentioned, if you're saving a single entity, you get back reactively one thing, and that's where we use that reactor monotype. In this case, I can save an employee and I get back a mono employee. I can do a save all for an iterable, and I'll get a flux of those objects, a flux of employees. Here's an example where we can consume any publisher type, which is a reactive stream. So there's other libraries out there like RxJava2 that they return back implementations of publisher, and you can feed them in here. So we have interoperability with other libraries that speak reactive streams, I meant. And here you can see to go find by ID, you can check for existence and find all, and there's counting too and deletion. So let's go back to the repository. So just by extending the interface, I already have a fully fledged set of CRUD operations without lifting a finger. This is one of my favorite features of Spring Data. But what's even cooler is that I can go define some custom finders as needed. And I'll go and look at that in a little more detail. But now that I've defined this repository, what I want to go to is I want to build a RESTful API on top of it. So I'm going to go create a Spring WebFlux controller. So here at the top, I've got this, for those of you not familiar with Spring Web or if you've never worked with Spring Web MVC or Spring WebFlux, this @REST controller annotation says this whole class, it's a controller, but all the responses are not, I don't want to render views. Instead, I want it to serialize the results and write them directly into the HTML response body. Now what I'm going to inject is I want to inject a copy of that repository, the employee repository that we just looked at. But I also need to get a copy of that database client that showed up in the slideshow. And we'll see where that's used. So this is a little bit of Spring's classic dependency injection at work here. So whenever Spring WebFlux reses up my controller, it knows to go find the employee repository database client and inject them in the constructor call. Which brings me, to the core thing here. Get mapping with a URL path. So basically, API/employees. It's my all method. I want to return back I want to turn back all the employees. And all I have to do is just invoke the repository's find all method. And it'll go and load up absolutely every single one. Now, if I'm doing if I invoke this API over the network, it may very well give me, if there's 100,000 rows of data in the database, it's going to start trying to serialize 100,000 rows of data. And that's where if you're able to actually connect to this over RSocket, if you're using something like RSocket, you could say, I want to do the find all, but I want to subscribe for 10 results. And the RSocket would only fetch 10 pieces of data out of the database, and it would only send 10 over the wire. It's not going, in proper reactive programming, you don't fetch 100,000 rows and stick them in memory and then send 10 over the wire. You only pull 10 rows out of the database. And then the counterpart operation I have is down here. I want to do a post on the same API on this aggregate root. And in this case, I want to signal that the request body of the HTML call is actually going to contain my employee type. So what I'm going to do is anytime somebody sends me a bit of JSON over the wire and it contains the details of the employee, what I'm going to do is I'm going to make a new record and I'm going to paste in the name and the role. But in case they sent me an ID, I'm going to drop it because I'm going to create a whole new one. So I'm going to leave the ID field empty, and that will let Spring Data R2DBC save it as an absolutely new row of data. And if you remember what the save operation does, the save operation hands me back a mono, which is a reactive type. So I've got the results. I'm going to map over them, and what I'm going to do is I'm going to basically wrap them with this. This is a helper method from Spring Web, where it lets me generate an HTTP 200 status method, an OK response. And in this case, it's going to actually grab the newly saved object, and it's going to copy it into the HTML response body. We can actually go run that. So I'm going to fire it up here. If I scroll here, you can see that it's here. It says it's executing the script from Schema SQL. It's gone and created my table. The other thing is we're running on Netty. This is not running on Apache Tomcat. One of the things you do is you need a fully reactive web server, and Tomcat is not 100% reactive, but Netty is. And then you can see that it actually ran those initial 2 insert statements. What I'm going to do is I'm going to actually flip to the terminal here. So let's ping. Let's make that look a little better. So if I go curl against that, where'd I go? Right off the page. Okay, so if I curl against that API employees, I'm going to get handed back a nice little list of that data that I loaded. So here it's talking. It gave me a 200 OK response, and that was the find all. So the find all returned it back to me. I can add new stuff. I mean, you can't run a company if you're not going to have Samwise Gamgee in your team. How about I put the URL in there? So it runs that. So it's doing a post call on API employees. I got my content type of application JSON. It gave me back a 200 response, and it actually printed out the new record that it made. The giveaway is that there's a new ID field, ID 3. And actually, I can go back and query that original endpoint. So now I can see I got actually 3 endpoints here. So now I can get the results, I can do postings, and it's all doing this reactively. Let's see if we can, okay. And here in the console log, I can see where, it was doing select star, select employee.star from employee. So I didn't have to write those queries. I wrote the statements that are in the schema.sql to create the thing, but Spring Data R2DBC used its query derivation logic to go write these other operations for me. And then you can see the insert statement that I did when I created a new method or a new object. So I'm going to stop that for a second, and let me close that. So that's if I do a get and a post against the aggregate root. And so if we're gonna start implementing a full-blown REST API, then we need to get down here and actually be able to look up single entities. So here's if you need to specify a URI template, and then you can map this ID field can get mapped as a path variable onto here, and then I can use the repository's find by ID to look up a single employee. Now it starts to get a little complicated if you say I want to implement a put operation, if I want to put at a given ID, because in the database, it's different operations. If you're trying to change an existing row, that's an update call. But if you're trying to insert a new row that doesn't exist, then that's an insert statement. So in this case, it could be creating or replacing something. I want the ID, but then I also expect somebody to provide me a actual JSON for the new employee that's coming in. So the first thing I'm going to do is check whether or not this ID even exists. And the exists by ID, again, everything is reactive. So everything's like it's like a chaining together a whole lot of little steps that you want to do, and then unwrapping them as you go. So this exists by gives me just a Boolean operation. So I'm going to check the exist flag. If it's true, I'm going to use a ternary operator. If it's true that it already exists, then use the update option. If it's not true, then do an insert. And for either operation, I'm going to expect to get the final updated record handed back, and once again, map that over a response entity OK operation and hand it back to the person so they can see what was done. So down here, I've got a couple private functions. One was this update operation. So in this case, if I'm updating an existing record, what I'm going to do is I want to go find it. I'm going to map over it, and I'm going to basically replace that one with this one. And I'm going to paste in this employee update information to override what was there. So I'm going to override everything but the ID field. And I'm going to save it. And then I'll hand it back. But for an insert operation, here's where I ran into some trickiness. Currently, the default paradigm with Spring Data R2DBC is that the way to tell if it's a new entity and whether it's going to do an insert or an update operation is whether or not the ID field is null. Well, here's a case where I know what the ID field is because I'm saying I want to insert it at ID equals 10 when there is no 10. I know what it is, so it's going to not be null, but it's still new. And I either need to go use a more complicated way to handle ID values and what's new and not new, which they have APIs for, or I can sidestep the repository and just use that DB client. Because I've established that I'm doing an insert, I can just use the DB client's Fluent API. I can insert into the employee class. So they're going to translate that as the employee table. I'm going to provide the POJO object I want. This is essentially do that, then wait for the results. And after the results happen, then what I want to do is then go back and look that up. So let me look it up, give me a properly formed employee object out of the database and return it back. So with this kind of stuff, it's easy for me to then go, you go put to localhost 8080 API employees. Let's go update Samwise Gamgee's record. Let's make sure we're setting some application JSON over. Name. And then role. Because I believe later in the movie, he in fact had to carry the ring, so he was actually granted credit as a ring bearer and actually was able to go to the Undying Lands later after serving as the mayor of the Shire at some point. Oh, it would help if I went and restarted the app. Okay, restart. Okay, so that means I'm gonna have to recreate them. Let me see, let me go create that. Let's check. Okay, we have the record there, and let's try that put operation one more time. So here we can see it sent the updated record, the 3, and it shows that he's a ring bearer. And if I go query that again, I can see the updated status. And here's where I can go put in a plug for the fact that if you're writing REST operations, when you do a put call, you really need to replace, it's a replacement. So it's not a update a single field type operation. Put means if you leave a field empty, it'll get nulled out. If you need to implement individual fields or something, you need to use a patch operation. So anyway, I was able to implement all that, and I say, okay, so now I can go read all the data, add new entities, read a single item entry, go update that one. So I'm on my way to building a fully RESTful service. The only thing I don't have is links built in, which if I had more time, we could add that with the Spring HATEOAS project because it has Webflux support, but that's not the focus of our presentation tonight. The last thing I want to add in my demo app is, in fact, let's build a search endpoint. So I want to be able to search on the data using R2DBC and Spring Data's implementation thereof. So let's create a, let's do a API employee search. In this case, we can have different parameters come in to tell us what to search on. So I can look for, it can either be question mark name contains equals whatever. If I want to just search on the name. In this case, I'm going to create a specialized finder that's going to query on that and then just return that back as a response entity, okay? Or I could look for, what if I want to search on all the fields? Well, then I can start to write this thing. I'm going to go over to the repository to show what that is and how you can do that and what your alternatives are in case you don't want to do that. So another feature, I mentioned earlier about Spring Data having what's called query derivation. It's possible for, what Spring Data will do is it'll actually go, if you create a find by, you can actually go specify the names of the fields, and the tooling actually supports this. If you want to go create another, if I start doing this, the tooling's actually popping up. It can read the entities and say, what do you want? You know, there's actually a lot of different paradigms to do this by. I'm like, okay, I want employee, find by name, or find by name, and you can start to create other things. But here it says find by name, and that would be an exact match. But if I want to make it a partial match, then if I add this contains, you can also say find by name starting with. You know, you can have it if you want to have it. Does the name start with that? Does it end with that, or does it just contains? And this will go query the database on this table and search on this particular field. So I thought, okay, let's do a partial name match. That would be a handy feature. And then another one would be, what if I want to search? I want one token and it matches either the name or the role. So here's what I find by name contains. So that's a partial match on name or a partial match on role. And it'll or the results together. And in this case, you can name this whatever you want to. It doesn't matter. The Spring Data knows to match the first argument with the first by, and the second argument matches with the second. And so back on the controller at the bottom here, if somebody comes in and provides a name contains, then I'm going to use the first one. Find by name contains, and the second one I'm going to use. If they provide this, I'm going to use the same parameter, but I'm going to put it in both. And if I don't get either of these, I'm just going to print out, hey, that's a bad request. And I'm going to help them say, did you do this right? So let's run that and check it out. Okay, so we're all started up. I'm going to, let's go create some, okay, yep. Let's do the put. Okay, let's reread everything. Okay, so we're all set back up. So now I can curl, let's see, let's do the search. You know, if I just pick something at random, it's going to say, well, that's no good. So, okay, so let me use it properly. Name contains, let's find all the baggins. Let's make it look nice with JQ. Okay, so it says here's everybody that has baggins in it. So you can find that. Make sure we're doing it right. What if I only look for Frodo? I'm just going to get Frodo back. Now the other one was just plain old contains. Let's see if I do that. If I look for contains Frodo, matches there. Contains, what about ring? Now I get back Frodo and Samwise. So here I've, been able to res up a pretty hastily an operable API. Now it's not, and it shouldn't take me much effort if I need to migrate this to a more permanent solution like PostgreSQL. But the idea is here I was able to go focus on what are the business needs that I need to do. I can with this at the controller level here, it's very easy to declare, okay, I need a put operation, I need it to do this. At the repository level, I can say, okay, I need basics, but I also need these kind of finders. If you're starting to write more complex stuff, there's other query options available. You can just put an @query annotation, write your own query. So if you need to write it by hand, a lot of times, this stuff out of the box may cover us for 80%, but we need to close the gap on the other 20%, and that's where @query is handy. There's also support for other query solutions like Query DSL, and and we saw a bit of the database client. So I'm going to exit out of this appearance. Let me get to exit presentation mode. And I'm going to go back to the deck. So what we currently have available, if you want to go reach out and start tinkering with R2DBC right now, it's at version 0.8. R2DBC has not reached a 1.0 status yet. So each of the drivers is at a different 0.8.1, 0.8.2, but it's the 0.8 version. And there's actually a BOM or a bill of materials. So you can pick it out, and it's named after it's a European city named Araba. So we're on Araba SR5. If you use the BOM, if you go to the website, it'll tell you how to get onto that. But we have implementations for H2, Microsoft SQL Server, PostgreSQL, and there's actually community projects, especially MySQL. There's 2 different drivers for MySQL. You can do today batching. There's a lot of type conversions. We have blob and clob support. There's save points transactions. There's even some database specific features. And I mentioned the connection URLs. You can go read the specification document itself if you want to see the SPI module. And we have there's pooling support. We already talked about some of the client solutions. And there's even some observability in effect. Like there's a proxy project designed to wrap all the operations. So if you need hooks in to wrap all the stuff in an elegant fashion, you can check that out. And we have support for metrics with Micrometer. So when we're talking about R2DBC, we've shown what it does have. Some of the questions come up. Do I really need to go down this path? Why can't I just grab a JDBC driver and wrap it in a thread pool? Well, there's some fundamental flaws with that approach. You can definitely find libraries that are doing this, but if you have an unbounded queue, you're going to use up all your resources. And if you have some kind of bounded queue, like the thread pooling solution that wraps it in a queue, says, okay, we're just going to hold a bunch of threads and we'll just round robin between them. If they put a fixed limit on it, then eventually you're going to fill up all the queues and it will then block you, and then you still have a blocking API. There's other stuff in progress. There's things like Project Loom, but Project Loom I don't think is coming until JDK 17, which would be the end of next year for an official first release. So you're free to wait till then to see how it turns out, and you need to go study and use their APIs, or you can start using R2DBC today. It's really beneficial to collaborate because I don't think the market's really in favor of let's have 5 different reactive approaches to database storage. We've already seen some of this take shape. There was an A2DBC spec, or no, A2DB or A2BDA, now I can't even remember it correctly. It was a draft spec put out by Oracle that had some early design stuff. We actually interacted with them and gave some feedback, and in the end, they really weren't interested in the feedback. So we said this was our cutting decision to say, let's go forward and work on R2DBC. And I believe that spec has been, in fact, abandoned, and Oracle has indicated initial interest in working on R2DBC, or at least being able to have their own driver. And that's where community adoption is key. We need, if the community steps up and says, this is a good spec, it's going to draw a lot of database vendors in to want to be a part of that. With database technology being sort of a commodity, then it behooves the community to do that. What is what's coming in the future versus, what can you do right now? We're looking to make some additions and improvements to the SPI. We don't have support for stored procedures yet, as well as auto commit or fetch size. There are additional driver implementations that are in the works right now. Google Cloud Spanner is developing one. SAP has a database called HANA, and the DB2 people are also looking into it. Oracle has expressed interest, as I mentioned. And one thing we're really, the VMware and the Spring team aren't really big on being vendor owners. It's really valuable if the vendor of a database owns the driver. So we're really big on being able to push out that kind of stuff to, as close to the database as possible. So if the PostgreSQL community wants to pick up and take on the R2DBC driver for that, we're very open to working like that. I've just gotten news today from Mark Paluk, who's the development lead on Spring Data R2DBC, that core parts of Spring Data R2DBC are actually headed to the Spring framework itself. Not only, we talked about query derivation and writing queries for you, that's a Spring Data feature, but the fundamental part of a database client, a R2DBC equivalent to Spring's JDBC client, as well as a reactive transaction manager and database populator, are all some key things. So those are pieces that are in flight to go to Spring Framework itself. And there's additional clients that are actually, we've been interacting with the, I can't remember his name now, the develops JUG. JDBI, MyBatis have some initial support. So they're all looking at it. And I think it's part of trying to find time. Some of these are community projects, and it's all, when can they find time to do that? But they look very interested in it. So you can track that. If you need some resources, I would encourage you to go visit our website at r2dbc.io. We have a Twitter handle at R2DBC, and there's an R2DBC GitHub organization where you can find all the code. There's also a mailing list for primary communication, and then there's I need to update the slide. There's a monthly call. I believe the first Friday of the month is at this time, but if you go to the website, it shows that there. So thank you, Atlanta JUG, for having me come here. I encourage y'all to go visit greglturnquist.com/AtlantaJUG, and over there you'll find a chance to sign up where I don't really blog anymore. Instead, when I sit down to write a technical piece, I share it with the people that have subscribed to my newsletter, the people that are really interested in that. So if you want to sign up for that, you can catch all my technical rants and ravings. And I also have a free handout for everybody that signs up, so you can go check it out.
Thank you very much, Greg, for coming out and presenting with us tonight.
Cool. Do we have any questions?
Yep.
Yeah, and I'm happy to hang around here and answer questions if I can get back to Zoom.
I have one. I have a couple. Can I go ahead?
Yep.
Go for it.
Okay. So my name is Rabi. I have actually attempted this with Postgres with a real-world database, and I did have run into some problems like the data types, like time zone. Date time with time zone is not supported with the Postgres driver, so I had to drop the time zone in my experimentation. So that tells you that I actually attempted. I can share my screen as well. That I actually attempted with a real database. My question is not based on that though. I'm sure that support is coming in the future for the Postgres driver. But if you can pull up your entity class, in a real world, not everybody has a chance to work on a simple start from scratch and write your entity class. You start from a 5-year-old entity class with 2,000 JPA annotations around it. Right. So my question is it even possible with annotations many to one and one-to-many mappings between different entities within a existing JPA entity to convert that somehow, evolve that into an R2DBC? Because what I've noticed is in your entity, you've added an ID annotation, which looks like a JavaX persistence annotation, but it's actually not. So is there like a future support that would come with other annotations, like many-to-one, like one-to-many kind of support?
Yeah, that's a great question. In fact, I think I saw a ticket go by today where somebody was asking about the one-to-many, many-to-one support and all. So something to clarify in the midst of all this stuff is some of you may have heard of Spring Data JDBC. It's something it's pretty recent in the Spring Data umbrella, and it's essentially Spring Data JPA is about let's use JPA, but let's see what we can do to speed that up, to simplify that. But a lot of people are very interested in JDBC. JPA comes with its own kind of bag of worms to contend with, and that's a deep road to go into when you start, the more complex your domain model comes. And I know of a lot of people that are like, I'd rather just write all that myself. I can write the JDBC I can write the SQL and use JDBC to do that. So Jens Schauder is the project lead for Spring Data JDBC, and so he's like, how much of Spring Data can we implement with JDBC directly without going all the way to the point of creating our own ORM? Because ORMs, there's a lot of blog articles and stuff about some of the challenges with maintaining full-blown ORMs.
Agreed.
But in the midst of all that, we started the R2DBC effort, and so there's actually Spring Data JDBC and Spring Data R2DBC are co-projects that inherit from a parent project called Spring Data Relational. So currently, Spring Data Relational doesn't have the one-to-many support like that, or it doesn't do it the way JPA does it. I'm not fully experienced enough to tell you all the ins and outs of that, but if I can find a link, I'd like to post it to there's also a Gitter channel for Spring Data.
Right.
I'm going to post links to, there's both an R2DBC channel to discuss stuff. Let me put that here. And we have a Spring Data channel where they sort of manage all the different Spring Data projects at one time. And so I don't have that issue on hand, but there's some challenges with that. Actually, I think if you go look for Spring Data JDBC talks by, I'll put it in the chat notes, Spring Data JDBC talks by Jens Schauder. He actually goes into a lot more details about how to manage that kind of relationship. And because there's a lot of stuff there's a lot of emphasis been put in, like when you use the repository pattern, you're getting into domain-driven design and concept of aggregate roots and stuff like that. So there's a lot of thoughtful design into how to manage that. It's not the same way that we do JPA.
Yeah. Okay. All right. Thanks. I'm just wondering, am I already doomed to start with an existing entity and try to convert it into and actually take the old driver out and put a new driver in and hope that I can use the reactive credit repository with that exact same entity and hope to work the same. So I was just curious to what your thoughts are. But thanks. I think I got your answer. Thank you.
I did see a question in the chat channel, which I can go ahead and answer here. Does R2DBC's latest version is 0.8.2.release? That suggests that it's not GA. Would you recommend using this in production? Well, I would say anything that you take to production, if it's not at a 1.0 status, you should evaluate that. Now, that is considered that is a GA release, but it's a pre-1.0 release. So I think that we're trying to signal if you go search Maven Central, there actually is a 1.0 artifact. And when we did that, we realized, hold on, we don't think we can cover the whole scope of what needs to get into a 1.0 release. So we basically abandoned that and said, we need to go to 0.8. We have a 0.9 in progress. So we want a chance to, let's iterate enough and get the SPI stabilized before we try to declare a 1.0 GA release. So whether that's enough for you to go to production or not, I don't know if I'd put my most critical systems on that yet, but in any shop that I've seen, it's built out of your systems are based out of lots of big and little apps. So you can look at maybe some of your littler apps that are easier to manage, maybe a starting point to go evaluate it and see if it works for you.
Any other questions?
I have a question related to a comment you made about HTTP and reactive. So my understanding of an experience of using React or Netty is that you could still use and create RESTful endpoints using the HTTP API that's provided by Project Reactor, but then it will provide whatever like back pressure or semantics, provided that you're in Java to Java. Is what you were mentioning there related to doing like interoperability between languages, or is it something else? Could you clarify that a little bit, please?
Sure. To be clear, RSocket really is a protocol, so it's not Java specific. So it's possible for you could have a RX Java 2 client that speaks reactive streams talking over RSocket to a Java backend service and have all the semantics of back pressure in that scenario. I don't know who all has reactive stream. I know about RX Java 2 and I know about Spring stuff. I don't know about other like Ruby or JavaScript for who all else has reactive stream support, but it's essentially a protocol that's able to transmit the necessary metadata in a reactive fashion.
Right. ReactiveX provides handlers for multiple languages, so I wouldn't be surprised if RSocket becomes, approved that they may adopt it if it becomes a de facto standard. But I was just more trying to clarify, if you're in the Reactor world and you have a client that's using, whether it be built-in HTTP client that's part of Java itself that's built on reactive streams, or you're using Project Reactor's web client, do you still get the benefits of back pressure using a pure HTTP API, or do you not? Like, I think,
well, I'm not sure.
That would be a misunderstanding. Like,
I'm not sure you can get 100% of the benefits of back pressure communicated over the wire unless you are using something like RSocket. So I think I think you're at risk of, maybe it depends on the scenario. Maybe you can get to 90%, maybe in a very high volume situation where it really is key to control.
So the scenario I'm thinking about is
something.
Sorry, just to clarify this, the scenario that I'm thinking about is if your response is a stream plus JSON response object that's sending a stream of JSON messages, would it be possible, if you're in Reactor world, to be able to leverage that? Would it be able to take advantage of that behind the scenes and do something, implement back pressure?
I don't know that one. I'm trying to think, like Rawson on the Spring team, probably maybe Mark Paluk would be able to answer that one, because I don't know the answer to that one.
Okay. And a second question that I had is just related to JPA. So you seem to imply that either you go full reactive or you don't, but have you seen any hybrid situations where if you do use JPA as part of your, like, for example, like if you have it in its own thread of execution, that it will cause any sort of performance problems over time, or do you just suggest not to even try those kinds of experiments and use something like R2DBC instead?
Well, what I have seen from a performance perspective, I don't do a lot of field interaction in my current job, so I can't say I've been on site and seen this. What I have seen is in benchmarking, when we're trying to squeeze out and say, where's the framework code inefficient, we've written some benchmarking code to sit there and try to, let's tax the system and see what we can do. And when you start using the reactive paradigm, it actually adds overhead to the system. So it adds, we've seen on the order of 25%. That's a big number. And so if you're using Reactor, but you don't have a lot of traffic or there's not a lot of activity, then it's almost like that's a situation where you could say Reactor's not worth that. But when you start to have to ramp up and you're actually having, maybe you have 100,000 users hitting your systems, and essentially you need something that's going to squeeze more power out, that's when you do need it, because then you really do need to harness the idle cycles, if you will. So the paradigm I have in my book is that all of our commerce operates through trucks. We load freight on trucks and send them down highways. Trucks don't go faster than cars, they go slower, but trucks carry more cargo per unit volume, so it's a higher throughput. So the whole concept of like boxing up work into lots of fluxes and monos and then unpacking them through the mapping operations, it's not worth it if it's not a high load. But if it is a high load, then it's a huge payoff. So that's where it depends. But generally, when you're doing reactive, the default is that you run as many threads as you have CPUs, or rather as you have cores on the machine. Because one thing we've learned over decades of observation is that thread context switching on the CPU is a huge overhead. So it's better to not have too many threads. So when you run something like JPA or JDBC, you typically run in a thread pool with 100 or 200 or 400 threads. And with Apache Tomcat, it's the same story. You need hundreds of threads. Nobody's got a 100 core machine. So to avoid the context switching, you need to scale down and be using 4 or 8. And if you're doing that and you're using something like JPA, you're going to use up the threads very quickly because they're all going to be blocked, and then you're going to block your users.
Okay, that makes sense. Okay, thanks.
Well, if there's no more questions, maybe it's time we do our raffle winners. Ari, do you want to step back? No, can't hear you. You don't appear muted, but we can't hear you, Ari.
But it sounded great, huh?
Yeah, there you go.
I'm going to go ahead and select. I'm going to go ahead and do the selection. It's not going to be a live selection process because I have people's personal information on it, but I have everyone attached to an Excel spreadsheet, and I'll be able to choose the 3 numbers shortly. So if you can do the other prizes first, I'll come back in just a couple minutes.
Sorry, we decided not to do those tonight and let you be the exclusive raffle. So.
Oh, really?
You need another couple of minutes?
Yeah, I just need like 2 minutes.
Okay, no worries.
Well, as Ari was going, I was going to lip sync for him and say, "Everybody's a winner! Yay!"
Hey.
You get a shirt, and you get a shirt.
Everyone here is a winner. There's no doubt about that.
Hey, that's right.
Well, if we're doing vamping, I can tell you one of my favorite requests that keeps popping up periodically is as people ask me, so when are you going to add reactive support for SOAP, for Spring Web Services? And my answer is never. That project, essentially, it provides an integration point for the existing SOAP solutions, and nobody in the SOAP land of these 15-year-old toolkits is going to add reactive support. So again, it's one of those, it's got to be a sort of top-down effort to use reactive. So I can understand it can be a bugbear to say, I like this app, I want to convert it to reactive. That's not, for big app, that's not necessarily an easy task. But they do have tools out there. The Reactor team is really, I talked to them and I found out everything I don't know about reactive. And they have tools like Blockhound, which can actually go sniff out blocking calls. They can, when you're running stuff, it'll go and detect, oh, wait a minute, buried down in this library, you did something that parked a thread. That's a blocking operation. And I'm like, I would not have caught that. I think I had some code that was trying to do session management, and it invoked the Spring framework, which went in and had to go invoke Java's pseudo random number generator, which is a blocking operation. And so I was like, I didn't comprehend how Sergey could build this Blockhound tool, but it's fabulous. So if you're going to get into reactive, you need to know this tool. And so there's like a whole section in the book where I've like talked about, here's Blockhound, here's how to use it. It's great. And all cheers for Sergey, who's developed this tool.
I'll second Blockhound. We use it in a project, and it is definitely good about catching all kinds of things. So outside of reactive data, Greg, is there anything exciting coming in Spring data, just in general? Sorry to put you on the spot.
No, I'm trying to think. I'm like,
all right, you can jump in too.
We have this balancing act with the Spring Data umbrella. We have like somewhere between 11 and 15 modules that are underneath Spring Data umbrella. So at one time it's like, okay, what new features can we implement or implement support for? And Christoph has done in the past 6 months has implemented support for MongoDB transactions. So MongoDB now has transactions in the engine, and we're trying to make it where it's accessible and works with, at transactional. So you want to do that. At the same time, we also need to update the modules because people like Elasticsearch is always cranking out new releases, and they're constantly breaking APIs. And so there's a community managed Spring Data Elasticsearch that's always having to keep up and keep bumping up the version. And so you have this balancing act of, we could either sit on a stable version and then we're going to be 3 versions behind what's actually supported from the database vendor 6 months from now, or we can keep moving along and we're going to have to keep up at the risk of breaking people. And so breaking APIs is something the Spring team has vigilantly tried to fight against, or at least without having a major version update. So something I learned about years ago is how Jurgen, they've got code. They would have code in there that's like, it compiles on Java 6. It could detect if you're on Java 8 and add optional support, but it still runs on Java 6. And I was like, how do you even do that? I couldn't even comprehend that. And then I saw how they did that, and that was amazing that somebody had thought of that 10, 12, 15 years ago. So it's like, so this breaking change is coming. Is this something we need to support in both, do we need to support the old version and the new version? Do we only support the new version? Do we have time to also go work on the new features that we need to tackle, like transaction support? And so,
yep, it's always a balancing act for new features.
All right. I have the winners.
All right.
Winner number 1 is Tony Amaro, Venugopal Chindambaram, and Jason Centino. All 3 of you are winners tonight, and I'm going to go ahead and email you and get your vitals, shirt size and address, and we will get those, and we'll get the Iron Frog shirt out to you. And also, only a couple of codes have been used for Swamp Ups, so if you were weren't going to grab one, feel free to register and grab one. And here's some really awesome speakers. That's just a select few, but we got some good stuff, and would love to share it with your community as well. Thank you, everybody.
Thank you, Ari. We really appreciate
Great
the
talk, Greg.
raffle prizes tonight. All right. Well, I guess we're going to wrap it up shortly. Any final questions for Greg or comments?
Thanks for the suggestion for block count. I did not know this thing existed. I'm going to really be playing around with it now to see where my
it's a love-hate relationship, because it'll show you lots of things.
It's better to know about it now before it goes into production, and then you start getting complaints from end users, right?
Yeah, that absolutely.
Go check the chat channel. I put a link to the bit.ly link so you can jump to, if you want to go take a peek at the book. If it's for you, awesome.
Thank you.
Thanks for letting me come here. This is great. I like to get out.
Thank you very much, Greg, and thank you, Ajug members. We wouldn't be here without you, so appreciate your time, and we'll see you next month.
Thanks, guys.
Yep.
See you next month.
Stay safe.